Calculus, Lesson 8.3, Part C. This is the washer method. Before you watch this video, you want to make sure that you understand the disk method, which was Lesson 8.3b, and practice that a bit before you do this one. This isn't super hard, but you do have to understand the disk method before you do it. So this lesson is going to be fairly short, actually, because the washer method really is just the disk method twice with subtraction. That's all it is. It sounds confusing, but it's really not that bad. So basically, instead of our object going all the way down and touching the x-axis and then spinning around and making a full cylinder, we're making something more like a washer. I'm thinking of like a washer, like nuts and bolts and washers that have like a hole in the middle. So if I spun this around, I would have a washer with a little bit of a depth to it here. And try to draw it 3D there. That did not work very well. Probably supposed to be up there. Anyway, you get kind of like a donut shape. And basically you're just taking the outside like as if it was a whole cylinder and subtracting the cylinder you would get from the inside. We can have all sorts of different shapes. These are kind of fun to imagine and what they would look like if we actually spun them around. So this one that I was just looking at, the picture of what that would look like in 3D is here. Taking that rectangle and spinning it around. This one we have this funny shape. Let's see what that looks like. It makes like a cone and you can kind of see this shaded. That's where it's going to be a little bit thick and curvy, like a funnel, but not a straight-sided funnel, kind of a round. That's fun. And this one, when you spin it around, it's going to be rounded on the outside and have a cylinder in the inside, like a bead. So those are kind of fun shapes to make. Anyway, my husband has a metal lathe and he loves to make stuff. I should put some pictures of his things on here. But anyway, the main idea with the washer is basically you're taking the outside, that one that you're spinning around, the pi r squared, they call it capital R, and then subtracting the inside one, which they're going to use lowercase r for the littler inside one. And then you're integrating that over your interval, dx, and these would be with respect to x. But because pi is a constant, we can just pull the pi out. So this is the formula with the pi out front. You can also do this with respect to y. Just make sure that your integrals of variation are on the y-axis and that you use y as your variable and integrate with respect to y. So let's go ahead and do an example of this. And I've only got one because this isn't much different than the disk method. So basically we've got this circle, this piece of a circle. We're only going to use this piece of it from, if you plug in a 3 to 3, because it's a circle. So I think that would work. So anyway, let's go up here. So we're going from the circle minus the line. And so my circle is the equation of the circle, x squared plus y squared equals 25, 5 squared. And then if I solve for that, for y, I get the square root of, and I'm only going to use the positive square root because we're on the top. So that's my first shape. So it's pi r squared, pi times the square root of 25 minus x squared. Squared would just be pi times 25 minus x squared. And then I'm going to subtract pi times this one squared. Well, there is no x. The equation of this line is just y equals 3. So it's just pi 3 squared. I can factor out a pi out of that. So I get pi, and then I'm going to set up my interval. Where is that? Is it from 3 to 3? If you plug in a 3, I think it's a 4, right? If you plug in a 3 in here, the square root of 25 minus 3 squared is 9, 16 squared of 16 is 4. So I believe that if that is a height of 3, then this is from 4. So I think we're going to go from negative 4 to 4. And we're going to do 25 minus x squared minus 9. 25 minus 9 is 16 minus x squared dx. So integrate that And we've already subtracted out the whole. So basically we took the whole coin thing and then we subtracted the cylinder in the middle. You can do that in your calculator and that would be the volume of this washer. So that concludes the washer method.